this is Roger Green, host of the Surfing the NASH Tsunami podcast. This weekend, we are offering 4 conversations and a full extra-sode from Season 3, Episode 14. Our discussion on complex balloon hepatocytes, the errors they cause in drug assessment, and how AI-assisted technologies can improve analysis. In this conversation, Mazen Noureddin and Jorn Schattenberg each pose specific questions about ways we might be able to improve trial design based on this paper. In the end, the 2 most important takeaways may be Quentin Anstey's observation, which Jorn shared, that we are placing a far greater burden on balloon hepatocyte analysis than it was created to fulfill, and my suggestion that we are underpowering our studies by focusing solely on statistical error, since in this case, the analytical and estimating errors surrounding balloon hepatocytes dwarf challenges of sample size. This issue has pivotal implications for all drug development going forward, and we all need to absorb its lessons. So sit back, listen, enjoy, learn, and when you're done, join the dialogue on our LinkedIn and Facebook discussion groups.
Congratulations, Quentin, on this landmark paper. It's kind of, if you're shooting, it's hitting the bullseye in the middle. And this is one of the fundamental problems we have in the field. Let me start setting the stage saying ballooning pathophysiologically is extremely important and one of the pathogenic features of the disease. And I do remember we tried to question ballooning and some people across the aisle started yelling saying, no, ballooning is the most important thing. And we are not underestimating that, but detecting it has been an issue. So I'm going to make bold statements and questions for you, Quentin. Given the screening failure rate and seeing many of my patients going into NASH trials, finding NAS score of 6 and fibrosis F3, but no ballooning cell, or let's say NAS of 5 and no ballooning cell, and they get kicked out from clinical trial. Based on your study, should this be call for action into reconsidering the whole ballooning in clinical trials? And I want to go as far as making it unethical anymore to really get fixated on the ballooning cell. Again, it's important, but we're not detecting it well. 2, should, I guess, a study like yours be the base of moving immediately toward using AI technology to detect the ballooning cells, or do you think you need a little bit more validation for this study moving forward?
Yeah, that's a really interesting question, Mazen. I mean, I think there are a couple of things we have to remember here. When ballooning was being described, when any of these histological features were being described, it was at that point a shorthand to allow a diagnosis to be made and to assess it in a qualitative sense. Because we are now at the phase of drug development and we're looking for endpoints and so on, we are in effect asking more from the histology than it was ever designed to do. So these semi-quantitative scores were not necessarily built to be a guide for therapy or something along those lines. They were built to help communication between pathologists, and we're now asking them to be quantitative, to allow us to tightly categorize and ascertain whether there's been a treatment response. So what we can take away from this paper and the others, such as the Davison study, is that we're probably asking too much of the existing techniques, and so we need to find a way to support ourselves with them. So I've been very careful about using the word assistive technologies here. I don't think this is about doing away with human histopathologist in trials, but what I think we would like to see, or what I would like to see, is the use of these techniques either to guide where ballooning might be, and that's something we're already seeing in radiology, for example, where they're looking at images and they have AI assistants to help them spot nodules that may be difficult or lesions that may be difficult in scans. So I think there's the concept of an assistive technology like that. The second step may well be that you use a human pathologist to confirm this is fatty liver disease, no, this isn't autoimmune hepatitis, but when you actually want to quantify and to therefore be able to detect change, you hand that over to a machine where quantification can be done in a much more standardized approach. So I don't think this is about a sea change in everything and that human pathology is not good. It's about asking the right question and using the right tool in the correct situation.
Sure. How about this? If I have a patient entry criteria as NAS 4 and higher with at least 1 point of inflammation, ballooning, and steatosis, and then they get to the F2 and higher. We know F2 and higher, they go into trial. There are trials that start F3 and higher. And we do know that the prognostic factor is fibrosis. Would you at least say NAS 4 and higher, any F2 for the F2 studies or F3 and higher, but you don't have to have 1 point on each one of them given a paper like yours as entry criteria.
So I don't think that that's really what the paper is speaking to, Mazen. The idea isn't about, we should therefore ignore what we consider. We consider that the presence of certain features is important for the pathophysiology. What we need to do is to assess those in a more standardized approach, not essentially give ourselves a free pass. And to your point about clinical trials, I suspect that you already do exactly the thing that is necessary to avoid this, which is when a biopsy comes back from one clinical trial and the central pathologist says, I can see F3, I can see steatosis, I can see inflammation, but I can't see ballooning, you probably say, well, great, thank you very much. I'll send that on off to the next trial and we'll get a different pathologist who will quite possibly see a balloon cell. So you're already doing what our study has demonstrated, which is that you can see certain pathologists are more or less likely to detect ballooning. And we saw that very nicely. There were certain pathologists who, if you like, tended to run hot, tended to see a lot of balloon cells, and other pathologists who tended to run cold and tended not to see balloon cells. So you're probably already doing that subconsciously.
Indeed, but that's costing patient another biopsy.
Actually, I can see a couple challenges with that, but that I'll come back to in a minute. But Joran, please go ahead first.
Quentin, thanks for your leadership in leading this effort. It's great to see also the group of co-authors you pulled together. They're so right on. I don't think the discussion is about what is NASH, because we're well aware of the clinical patient phenotype. And the discussion in your paper and the points you highlight is that we're probably over-probing liver histology. We're asking more from liver histology than it can give us. That's my take-home. So my two questions for you is, do you see a way to augment histology by using a liquid biomarker on top of it, combining it with a surrogate compound score? And the second thing is, did you discuss some staining? Because the field always says that if we would have a specific stain for a balloon cell, this could be one way also to augment it and move it forward.
Yeah, so I'll take the second one of those first, and I'm going to plead jet lag, and I may ask you to repeat the first one again, John. But in terms of the specific stain, the problem is there isn't. There have been a number of things proposed, like sonic hedgehog, for example, which potentially are helpful in detecting balloon cells, but there isn't a ground truth. There isn't one thing that if you stain it with this, the balloon cells all light up, guaranteed. Because otherwise we'd use it and there would be no need for everything we're doing here. That's one of the problems. Yes, there are a whole number of different stains that might help, but where do you draw the line with them? And as yet, we don't know if they're responsive to therapy or anything else. So it becomes more difficult. And what was the other bit again? Sorry.
So let me rephrase. The second question was, you discussed the technical challenges that different pathologists do not call a balloon cell all the same time. Are there biomarkers, liquid biomarkers that can help us to enrich and find more balloon cell in a patient? Is there an omics signature of ballooning in NASH?
Yeah, so one of the things, and this is one of the things that I'm quite excited about. So obviously you and I have published jointly and with Stephen as well, a number of studies looking at transcriptomics and looking at proteomics and so on in fatty liver disease, and another paper on lipidomics actually has just been accepted for JHEP reports this week, which will be coming out quite shortly. But all of those at the moment are founded on light microscopy and human pathology. And I think one of the things that will potentially help us to identify better biomarkers is to take away the intra-observer and intra-observer variation by using a digital approach and then repeating some of those omics studies, which will be very informative in their own right. So I think there's a piece of work there. In terms of what can we do right now to help us identify balloon cells, well, I think there we've got a few things. So there are very few biomarkers that are specifically designed to detect steatohepatitis and then do it well, as you know. So we don't have many. People have proposed things like cytokeratin 18, so. The one that's potentially a bit more interesting is, of course, NIS4, where it was specifically designed for fibrosing steatohepatitis. Wet biomarkers like that potentially have some leverage here because they at least will allow you to enrich your biopsy population for the presence of steatohepatitis, which is also the presence of ballooning. So that's probably the way it will guide us, but that doesn't necessarily mean that you completely rely on the NIS4, for example, to supplant biopsy. I don't think the regulators are quite ready for that one yet, although with time maybe they will be.
Thank you for great questions, and Quentin for great answers. I want to make one really quick observation. I've heard this phrase semi-quantitative for as long as I've been talking to you folks, and it's always rubbed me wrong, and I've never figured out why until I was listening to you today, Quentin. The problem with semi-quantitative has to do with the definition of statistical error, which is that when we define statistical error in terms of some measure, variation from a measure of central tendency, what we're assuming is that all the data that goes into that measure is equally accurate. Because it's semi-quantitative, by definition, that can't be right. So there's going to be the error that we can track through sample, and then there's going to be the error in observers, which will vary depending upon what you're measuring. But we now have the Davison paper and this work to tell us that the semi part of semi-quantitative and the error associated with semi dwarfs the error associated with quantitative per se. So we're powering studies based on the assumption that error is all statistical. And in fact, error is far more observational than it is statistical, and you can't put error margins around that stuff. You simply have to improve it. And the way to improve it is either forget about it or quantitate it. So when I listen to you and I listen to Mazen, I listen to Mazen asking, well, are there situations where we should forget about it? And you saying, really, what we need to do first is figure out if we can better quantitate it. Does that make sense?
I think you've summarized that brilliantly, Roger. And that is the point. We have techniques, we are developing techniques that will help us to better quantify it. It may be the HistoIndex platform. Others are available, such as PathAI. All of these give you a stabilized read, and they can probably all be improved, but that already is an important step forward.
And now, back to Roger.
This conversation is sponsored by HistoIndex, the world's leading specialist in stain-free AI digital pathology solutions for NASH clinical trials. Join HistoIndex for its complimentary webinar, Deciphering NASH, Fibrosis Dynamics in Cirrhotic Patients and Insights into Balloon Hepatocytes Using AI. That's a mouthful. At 11 a.m. Eastern Daylight Time on Tuesday, March 23rd. For more information about that podcast, visit the Season 3, Episode 14 or HistoIndex sponsored pages on the Surfing NASH website. We hope you've enjoyed this recording. If you have any questions or comments about the content of this conversation or the entire episode, please send an email to questions@surfingnash.com. We'll be back next week with a review of high points from the NASH Connect and Liver Connect meetings. Until then, stay safe, surf on, see you on the podcast. Bye-bye now.